Deep beneath the surface lives a creature so long it rivals a school bus. The giant squid, stretching up to 45 feet, has fueled myths of krakens and sea monsters for centuries, yet in a twist that feels almost impossible. It is not the largest squid on the planet. Evolution shaped another titan shorter but far heavier, a creature with more than twice the mass packed into its enormous frame. The colossal squid. Two giants that never meet, living in different oceans, growing to unbelievable size without ever knowing the other exists. How did the ocean create two monsters in isolation, and could it ever create a third? Most people assume the giant squid and the colossal squid must be close relatives, two branches of the same monstrous lineage. But the truth is far stranger. They are not the same species, not the same genus, and not even part of the same family. Their first shared category is only at the level of order, both belonging to Uigopsida, a group of deep-sea squids that roam the open ocean. All other squid species, even the larger ones, never reach dimensions that justify the word giant or colossal. Some grow long but stay feather-light, others stay thick but rarely pass 150 pounds. What makes their existence even more unusual is that they evolved in completely separate regions of the world. Their habitats never overlap. They have lived entire histories without ever crossing paths, unaware that another enormous cousin even exists. So how did nature produce two massive squids in total isolation, and what forces would be required to shape a third one someday? Both giants trace their distant origins to an ancient Uigopsid squid that likely lived between 60 and 100 million years ago, near the end of the Cretaceous. Yet almost nothing about these early squids is known. Their bodies were soft, fragile, and left little trace. Without bones, most of a squid disappears within weeks, not millions of years. The rare exceptions are their beaks, the only hardened part capable of surviving long enough to offer hints about their past. At some point after the dinosaurs vanished, this ancestral line split. One branch led to the Archaeoteuthidea, the family that would eventually produce the giant squid. Another became the Cranchidae, the glass squids whose lineage gave rise to the colossal squid. Although both descendants ended up enormous, their size was not inherited from a single giant predecessor. Instead, each species evolved gigantism on its own, a textbook example of convergent evolution. Different paths, same solution. But if their gigantism is convergent, why are they still so different? The answer lies in their environments. The colossal squid grew massive through the combined pressures of deep sea life and polar gigantism shaped by the freezing Antarctic. The giant squid grew large through deep-sea gigantism alone, thriving in the dark, high-pressure depths of temperate oceans. Two challenges, two environments, one evolutionary outcome. Despite both becoming giants, the two squids grew into completely different shapes. The giant squid, long and streamlined, can weigh around 500 pounds, built for speed and reach. Colossal squids are far heavier, with the largest specimens estimated at 1,300 pounds, making them the heaviest invertebrates on Earth. Their bodies are thick and muscular, shaped more like a living tank than a sleek hunter. While exact measurements are difficult to obtain, scientists estimate that giant squids may reach speeds near 25 miles per hour using powerful jet propulsion, the same mechanism all squids share. Colossal squids use jet propulsion as well, but their enormous weight likely limits them to roughly half that speed. These differences emerged because each species adapted to a distinct world. Giant squids evolved in open temperate oceans where prey moves fast and agility matters. Colossals evolved in the deep Antarctic where conserving energy defines survival. Instead of chasing prey, they wait in the cold dark until something crosses their path. Their tentacles showcase these differences clearly. Giant squids grip slippery, quick-moving fish with suction cups lined with tiny teeth, while colossals use rotating hooks built to restrain powerful prey like Antarctic toothfish. Even their shared beak, stronger than bone and made of layered chitin, evolved as the perfect tool for killing in the open ocean where nothing can be pinned down. It slices muscle cleanly while the radula grinds the prey before swallowing. Same purpose, different paths. Even if a giant squid drifted into Antarctic waters, it would never meet a colossal. Giant squids inhabit the midnight zone while colossals sink thousands of meters deeper into the abyssal zone. Two worlds separated by pressure and darkness, destined never to cross. In a strange way, their isolation protects them. If they ever met, they might simply attack each other. There is, however, one creature that knows them both intimately, the sperm whale. It is the only predator capable of hunting both giants, diving thousands of feet, guided only by echolocation. Scars from suction cups and hooks cover their heads, and in their stomachs, researchers have found the indigestible beaks of both species. To a sperm whale, convergent evolution is perfect. The more massive squids the ocean creates, the more meals await in the dark. But this also creates an endless arms race. Squids grow larger, faster, and stronger to avoid being eaten. Sperm whales evolve deeper diving abilities and longer breath holds to pursue them. Yet both sides remain bound by the limits of their environments. Convergent evolution does not exist to build monsters for spectacle. It produces designs that work because the ocean demands them. Just as dolphins and sharks share torpedo-shaped bodies or bats and birds, both evolved wings, giant and colossal squids found the same solution to survival shaped by different pressures. If evolution produced two enormous squids without ever letting them meet, could a third giant someday rise from the deep? The ingredients would be the same ones that shaped their predecessors. An environment defined by darkness, crushing pressure, extreme cold, or a combination of all three. Under those forces, gigantism becomes an advantage rather than a burden. We may already be seeing the early stages of this pattern. A few lesser-known squids seem halfway along the same path. The Dana octopus squid, short and wide, can reach around 350 pounds. The robust clubhook squid grows up to about 13 feet. Far from the colossal scale of true giants, yet their bodies hint at the first steps toward something larger. Given enough time, isolation, and evolutionary pressure, a new titan could emerge, shaped by the same rules that sculpted the giant and the colossal squid. Every creature alive today is a design refined by time, shaped by pressures that reward what works and erase what does not. The massive squid blueprint is no exception. It survives because the deep sea demands strength, endurance, and bodies capable of thriving where almost nothing else can. Convergent evolution does not create giants out of whim. It follows a pattern that has proven effective again and again across the history of life. Wings formed twice. Streamlined bodies formed countless times. And in the dark ocean, gigantism found two separate paths to the same result. So what future giants might emerge if the deep continues shaping life the way it always has? Perhaps another line of squids now unseen will someday grow into something vast and unforgettable. But for now, the ocean holds only two true titans. And the fact that they evolved entirely apart, never meeting, never knowing the other existed, makes their story even more extraordinary. The deep crafted the same monster twice simply because the design worked.